globally with a significant incident occurring in Asia. It is known as one of the most dangerous events, causing serious land and environmental degradation. Indeed, besides the loss of a huge quantity of plant species, the effect of fire can lead to desertification, increased risk of landslides, soil erosion, death of animals, and economic damage for the community. For this reason, mathematical models able to predict fire spreading are needed in order to organize and optimize the extinguishing intervention during fire emergency. In recent years, the use of GIS technology has increased for environmental management and monitoring purpose and predominantly as a decision support system, or we call DSS. GIS technology is also used for fire analysis and to forecast and manage woodland fires. GIS allows the implementation of mathematical models for the spread of fire or for fire management to determine. For example, the optimum distribution of hydrant, the location of fire station, the classification of fire regions according to fire type, and the creation of region-specific area intervention plans. But what are the factors of forest fire? The first factor is topography. The second factor is combustible fuel. The third factor is weather condition. And the last factor is human impact. Given that forest fires are caused by many factors, it is necessary to consider various influencing factors as much as possible for high-precision fire risk mapping in specific regions. So now, what are the methods in forest fire risk mapping?
Method of GIS. The first method is satellite remote sensing. It utilizes multiple sources of satellite remote sensing data to acquire picture and image interpretation. There are a few types of satellite mostly used like GFCs, Sentinel-2, HD2A, and Landsat-8 satellite remote sensing image. Sentinel-2, Landsat-8, and HD2A data were used for visual interpretation, while GFCs and Sentinel-2 data were used to extract and burn area that involves. The second method is meteorological data. Meteorological data were gathered from real-time data from meteorological station. This meteorological station provide temperature, wind speed, soil temperature, humidity, and rainfall data. This data was important to digital elevation model to create more accurate and efficient raster geometry. The third one is satellite imagery. It used two satellites flying same orbit but faced at 180 degrees, result in frequency of 5 Gs. The satellite image download and used in NDVI calculation. And the last one is aerial LiDAR data. It showed a survey grade centimetric accuracy and intensity calibration. There are also a few calculations involved to collect the data such as Normalized Difference Vegetation Index (NDVI), Normalized Burnout Ratio (NBR), Evidential Belief Function (EBF), Weight of Evidence (WOE), and Bioweather Index. All of these calculations have its own equation according to its suitability to its method. All of this information will be uploaded in GIS platform. GIS is a solid platform to use and process all this data that can help us see a picture on any relationship among data and helps in making organized planning for forest fire risk mapping.
The result is Laotian National Forest Park area. Laotian Park is located in the northern hemisphere and the south side is easier to receive sunlight. Thus, the water content of vegetation is less and the temperature is higher, so areas in this direction are at high risk level. TWI is a hydrological analysis of DEM data. It considers the effects of topography and soil characteristics on soil moisture distribution. The higher the TWI, the higher the moisture content in the soil. The more humid the land, the lower the probability of fire triggering. Therefore, the fire risk of area where has high TWI is low. It is shown in figure D. Figure B and C show the base layer classification of aspect and slope respectively. It can be seen that most of the step areas are at a place which has a high elevation and the surrounding areas are flat. The maximum slope of this area is 37.37 degree as the terrain of Laotian National Forest Park is relatively flat and there are few step areas is high risk areas. It can be seen from figure C that most areas are in low risk level. NDVI is the normalized vegetation index with a value ranging from -1 to 1. A value less than 0 means that the area is covered by water, snow, etc. If NDVI is 0, it indicates that the area is covered by rocks and bare soil. The value is greater than 0 means that the area is covered by vegetation. The higher the vegetation coverage, the greater the NDVI value. The central part of Laotian National Forest Park is a forest area with full vegetation coverage as shown in the figure. The marginal areas of the central rear are roads and populated areas, so the vegetation coverage is low. Thus, the fire risk of this area is high. The NDVI base layer is shown in figure A. Laotian National Forest Park belongs to subtropical monsoon climate. Its average annual temperature is 15.3 degree. From the figure that the temperature over 29.29 degree of these areas is close to 50%. Therefore, the fire risk in Laotian Park is high. According to the temperature division in figure, we divide the risk level of temperature in this area into 5 levels, and the distribution result is shown in figure B. This figure shows the main roads in Laotian and is split into 5 levels according to the distance to road. The closer the distance, the more vehicles and frequent human activities, which is easier to cause fires. Most human activities areas are not more than 1,200 away from the road. So this division method is reasonable in this area. The base layer classification of this is shown in figure A. And this is an example based on the distance between the forest and the populated areas. The areas with a distance of less than 400 meters in this figure are mostly scenic spots in the forest park, where human activities are frequently. Cigarette butts and sparks from burning incense are easy to ignite the surrounding forest. The area with a distance greater than 1,600 meters, most of these areas are densely forested areas with less human activity, so the risk of fire is lower.
As conclusion, forest fire risk mapping is regarded as an effective and important tool for fire forecasting, which is essential to manage and protect forest area. Accurately predicting the probability of forest fire and mapping scientific forest fire risk level can help Forestry Management Department to make scientific and effective forest resources management decisions. All things considered, mapping fire risk plays a crucial role in forest fire management because knowing the location with the highest risk is essential to minimize threat to resources, life, and property. Remember, forests are the lungs of the earth.